Okay, so for today, we are going to look at we're going to look at a couple of things. We're going to look at color scales. So we've already been using color scales a lot in our in our demos and on our homeworks, but we're just going to kind of go over them again today. We're also going to look at layouts, D3 layouts. So D3 has a number of layouts for implementing visualizations that require you to transform or kind of derive a version of the data. So something like a pie chart, right? It's a bit more advanced layout. So D3 has a pie layout that you can use, right here. So there's a pie layout that you can use on your data, a pie generator, and transform your data so you can easily visualize it using a pie chart. So it's kind of similar to a line generator, if you remember the line chart demos that we've done. So there's pie generators, there's what else? There's a lot. Cluster generators. The force generator is what we use for network visualizations. So we'll talk more about force next week. But so implementing, visualizing a node link diagram is what I could use the force generator for. You can also use it for things like a bubble chart or a B-swarm chart, or even in a scatter plot, you can use the force generator to do things like collision avoidance, right? So I don't have points sitting on top of each other. I can force them to move apart. So we're going to touch on those today. Based on what y'all have presented in your project proposals, right, a lot of you will be using these layout generators for at least one of your visualizations. Okay, but first we're going to look at color. So in the All right, so the code for today is on our class GitHub. It's in the 06 folder, and there's an attached README. So especially in these later coding demos, I've put a README on almost every one of them. I very much encourage you to, I put those READMEs there for a reason, right? So you can go back and look at them. If I say something that's confusing, right, you can go. Maybe if someone else says it in their own tutorial, right, it clicks better than the way I describe it. So, so especially if you're having trouble on a homework, right, I don't know how to do joins correctly, right? There's a lot of joins links on that demo. Okay, so the first file we're going to look at today is this color HTML file. So this is what the file looks like. We have a big SVG right here, and we have kind of a table arrangement with a bunch of labels on the side. These are going to correspond to different color scales that we're going to use. Yes? Oh, can I turn on? I might be able to turn them on. Over, okay. Better not send me to the wrong side of the room. Will someone turn them on? A lot of buttons. See, the affordances for this are not very clear. Nope. That one says on and off. Is that better? Do I need to make the code bigger? A little bit bigger. I'd hate to ask y'all to move closer to the board, so we'll just make it bigger. Okay, so so we have this. So we have our table here. We have a bunch of labels here, and then we've got like kind of one row of circles here with a bunch of numbers above it, and our SVG is really big, so we're going to kind of fill it up with some content. So on the HTML, right, this should be very familiar by this point, right? We've got a head section with some CSS, we're defining some CSS for the circles and the text we're going to put. And then we have our first div right here. So this is where we're going to draw. This is the logic we're going to use to look at different color scales. We're going to look at different color scale examples. So we have a data array, which corresponds to these numbers right here. Okay, so the data set that we're going to use for these demos is this data array right here. Okay, and so we're going to draw each of these objects, as a circle for a row using different color scales, different categorical color scales, some manual color scales, and so on. So just some helper code to start things out. We're going to get a reference to the SVG. We're going to get its width, the width of the SVG, and we're going to compute a step size. So the step size is just the distance between the circles. That's all the step size represents. Then we're going to add some text labels right here. That's what this code is going to do. So that code is going to add these text labels right there. So you might notice we're using kind of the new way to add it, the join methodology, the join syntax. So I just say .join text, and then I can, I give it a class, I give it a text label class, and then I set the x equal to 10 right there, and then I increment the y by 40 pixels for every label. So we go down 40 pixels for every row. Okay. And then right here, what this code is going to do is it's going to draw these numbers at the top of our matrix, or the top of our grid. Okay, so we're just going to show the data array, right? These data numbers here, we're just going to plot those. Okay, so this is all of our setup code to get to kind of our starting point to look at the color scales. Okay, so what do we say here? Categorical color scales are for showing categorical or qualitative attributes. Okay, so the documentation for these scales, you can just go here. So in D3, they call them ordinal scales. So the idea is you have lots of groups, and we want to assign a color to each group. So we can do this using a predefined color scale, something like this. So I say categorical scale 1 is a scale ordinal with a predefined color scale called scheme category 10. So that color scale should be in the documentation here. I think it's one of the first ones, not right there. Yeah, right here. So scheme category 10, it's a categorical color scale with 10 different colors, color hues. And then we say domain data. So, right, so each item in the array, that's the domain. So the first color, the blue color, will map to the first item in this array. The second number will map to the second, and so on. Okay, and then we plot that just like this. So we're going to draw each data item as a circle using this categorical scale 1. All right, so we've already done that. Now, the thing to notice here is in our data array, you see that we repeat 3 twice. Right? 3 is repeated, and 10 is also repeated. So, right, so we keep the same color, right, the orange. So orange is the second item in this color scale. So because 3 is the second item in the array, that's gonna map to the second color hue. Okay. Okay, so here's another color scale, categorical scale 2. So this one is going to be, I'm going to define the color scale. Okay, so if I want to define my own color scale, I can say scale ordinal, and then I don't pass an argument to that, right? I don't pass a predefined color scale as an argument. But now I need to add this range specifier to specify the colors that I want to use. Okay, so if I save that, reload the page. So now you can actually see, like, notice how the numbers repeat, right? Red is the first color hue that we have, so it maps to the 1. White is the second color hue that we have, so it maps to the second item in our array. And it also repeats, right, because we have 3 twice, so it's going to repeat. Blue maps to the third one, but because we have more values, 1, 3, 6, 10, right, there's more than 3 values, but we only define 3 color hues in our scale, we're going to start repeating. Okay, so we go back to red, white, blue, so on. So this also happens in the first color scale. You might notice that 20 is the same blue color as 1. So the color scale itself has 10 different color hues, but we have 11 different numbers in the array. So we start repeating. Okay. Clear so far? Clear as mud? All right. Okay, sequential color scale. So these map ordered data. So we can create a manual linear color scale using scale linear. So not scale ordinal, but scale linear. So I could say something like D3 scale linear, domain, just whatever the extent of my data is, right? So that this will return an array with 2 items with 1 and 20 in it. So that's what D3 extent's going to do. And then the range is just 2 color hues. So these are predefined HTML color hues, light green, dark slate blue. But I could give it an RGB value. I could pass like a hex value. 2 colors that are recognized by HTML. Okay? Right, so this is actually very similar to, like, right, I could also do something like this if I was plotting this on a scatter plot, say. Right, my range wouldn't be colored hues, wouldn't be colors, it would be, you know, like 0 and like the width of my chart, something like that. Right, so it's the same process here, except instead of going between 2 pixel endpoints, I'm going between 2 colors. So if when I draw those, right, you can see that it linearly interpolates between this light green and this dark slate blue color. Now, as I note here in the comments, right, so one problem, interpolating between 2 colors, right, D3 will do a linear interpolation if you use a linear scale. That doesn't actually match our human perception. So if you remember the color lecture, right, like humans can see a really rich amount of green colors. Like we're really good at seeing greens. And blues, we're also really good at seeing blues. We're very sensitive to those colors. We're not as good at seeing things like dark colors, like black or gray, or reds. We're not as good at seeing red colors. So, right, linearly interpolating between 2 color hues doesn't actually match human perception. So you can still do this, but you know, from a design perspective, it's a little suboptimal. So better, you know, to do something like, you know, I could say dot range, you know, white to black, something like that. Oops. Something like that. Right now I'm using brightness or luminance, right, which is a better match for human perception. Okay, another manual color scale, So I can also add middle values in colors. So something like a diverging color scale. So what we're doing is we're computing a start, middle, and end that goes into our domain. So the middle value, right, you can choose that value. So you can see I'm doing it here in the code. I have a min, a max, and then I have some middle value. So like the mean or the median. Maybe if I have like topographical data, zeros is the midpoint that I want, right? If I have negative values and positive values. Right, and then when I define the scale, my domain has three, it's an array of 3 with a 0, my minimum, some middle point, and a max. Right? So I could replace that with median, right? Or whatever value I wanted, right? Like 18. That's perfectly, D3 will accept that. So then when I draw that, right, my average value right, so the mean is 11, the median's 13. Right, the average is 11, median's 13. So that's what's gonna map to this middle yellow hue. Okay, so let's look at another example. Let's create a sequential color scale using a predefined palette. Right, so D3 also gives you sequential scales. Right, if you look at the documentation, right, there's the categorical scales, like scheme category 10, right, and there's lots of options for that. They also have diverging scales and sequential scales, right? So they have single hue scales, and they also have some multi-hue scales. So if you remember from one of the previous lectures, I briefly mentioned that the rainbow color scale is actually considered pretty bad, right? Because we don't know, is green more than red? Which one's higher? Or is purple higher than red? Right? There's not like a natural ordering to that. These sequential scales that are built into D3, one nice thing about them is they actually also vary, I think it's luminance. I think they vary luminance. So you can actually, it kind of, you can see it, one, if it's in grayscale, but it also helps order the data if it's in grayscale. Right? You can kind of see the lower to higher luminance. The other thing about these scales is they're designed to be more perceptually accurate. So like the green band, the sensitive parts, they try to design them so that it's more linear for us. So going from green, going across green is the same as going across red. Does that make sense? Like you can see in this one here, the turbo scale, like the orangest red section is a lot bigger than the green section. Okay, so I could do one of those. So Viridis is one of the scales. Right, so this is a perceptually uniform color scheme. Right, so it's a sequential scale, and if I save that, it'll plot it like that. Okay, a couple other quick examples. Quartile and threshold scales. So this is a way to bin data. Right, so maybe I have sequential data, but I want to bin it into discrete color bins. So a quartile scale separates the data into roughly equal bins, and they try to do similar sized bins. Threshold scales, right? I can define what my bin cuts are, what my segments are. Okay, so let's first look at doing a quantile scale. So I can say D3 quantile scale. Again, I get the min and max, and I define, so there's going to be 3 bins, for this data. So this quantile scale is going to try to make a lower 1/3 of the data, a middle 1/3, and a higher 1/3. So if I plot that, you can see it. They've tried to bin the data into roughly equal bins. So like 0 to 6 or 7, 10 to 13, and then 14 to 20. So bins of about 6 or 7 size. So here's an example where I'm manually defining the thresholds. So this is a scale sequential quantile, and I'm predefining what my thresholds, what my bins are going to be. Right, so if I plot that, you can see that I'm taking this existing sequential color scale, right, the Viridis scale, but I'm extracting specific bins from that scale. So the first bin is going to map to the lowest setting on the Viridis. The highest bin is going to map to the highest setting. All right, and then the last color example, I could also do something like this here, a threshold scale. So what this is going to say, everything below 10 will be red, 10 to 14 will be white, above 15 will be blue. So if I say that, that's how it's gonna map it. Right? So I'm manually defining what my cut points are. Okay. So lots and lots of ways to do scales in D3. There's several more that I'm not really even touching on. So hopefully by this point, y'all are at the point where if I don't know how to do something in D3, right? I can go look at not only examples of how it's been implemented by other people, but I can go look at the D3 documentation and figure out, okay, what are the color scales that are available to me, or how do I do layouts? Okay, let's look at a couple of layout examples. So the first one is just going to be a histogram. So there's some links here in the code to examples and documentation on histograms. A histogram is going to use a bin layout. Okay, so we're grouping data into bins, and then the histogram is going to show the distribution of the data by visualizing the bins. Okay, so let's see what we're doing here. So we have a height. So this is just going to be the height of the chart. We'll define the width, and we're going to append a G element where we're going to draw the histogram. So we have a for loop here that's going to generate our data, 200 random numbers between 1 and 500 with a normal distribution. Okay, so we have an array that we're going to use. We generate those numbers according to this distribution, and we add it or push it onto the array. Okay, so this will create an array with 200 data points between 1 and 500. So we're going to create the X and Y scales. So there's the X scale at X-axis. All right, we append that. My writing here is pretty bad. And then we're going to use a histogram generator to bin the data. So we define a number of bins. Right, so this could be whatever I want. I could change it to 10 or 100 or whatever. And then we say D3 histogram. So what this is going to do is create a histogram generator, and then we're going to call that generator on our histogram data set, on our set of 200 numbers. And it's going to create a bunch of bins. So if we go look at this in the JavaScript console, okay, so if I go look at this, Right, so you can see all the bins that we've created here. Right, so the first bin has so many points and like that. So this is the data that we can actually use to visualize. Okay, so let's create the Y scale right there. And then we'll just draw the histogram like bar chart. So we're not drawing the raw data. We're not drawing this hist data, array. We're drawing the bins array. That's what we're using to draw. What we use to create our Y scale, and it's what we actually pass to this to the function that's going to draw our data. And we can draw it just like a normal bar chart. Okay, any questions about that? All right, if I wanted to, change the number of bins, I could just, let's see, where do I do that? Yeah, I could change this, reload the page, and it would do that. All right, let's look at a similar example, a density function. So a density function is similar to a histogram, except instead of drawing the data as a bar chart, we're going to draw it as a smoothed density function. So this is so D3 Graph Gallery has some really nice tutorials on different techniques. The one they use on density plots is pretty good. Right, so it's going to look similar to a histogram, except instead of having discrete bars, we have this nice curve. So we need a couple of things for this. We need a function that's going to compute our density. So a kernel density function. And what this function is going to do is it's going to take these data points and kind of create this nicely smoothed data set. So you don't really have to know exactly what this code does, but if you wanted to do a density function, you would need, you could copy paste this code for yourself and use it. It's also in the example here, I think. Yeah, so they have a similar density function that they use. So we're going to use this kernel density estimator to, so we're going to pass our histogram data set to this density function, and it will create this density data set. So let's look at that in the console. So again, it's pretty similar to the histogram. So this is the histogram array right here, and this is the density function. Okay, the density function array. So one thing to note here. So notice how here the values are actually a lot bigger, right? Like this goes to 20. Here they're very small. So one thing about the density function, it's not going to go all the way up to, it's not going to be between like 0 and 10 bins, or 10 items in a bin. It's a lot smaller than that. All right, so another thing we have to do is we need to add a start endpoint just so that the data looks correctly, so it renders correctly in the area chart. So then we create a y-axis, and we can draw the density function as a line chart, so as a line chart generator, like this. So if we give a line chart a fill value, it'll actually create an area chart. So if we don't have this here, should, no. Yeah, there we go. So, yeah, so, right, so normally this would render as a line chart, but when you give it a fill value, it actually will render as an area chart. But the way we draw it is very similar to a normal line chart. You see we have the datum, we're drawing the density. So the density itself is just going to be an array of x and y points that we draw using a D3 line generator. So that's how we're going to draw it. Okay. So I know that's very fast. I kind of skipped over some stuff. If you want to use an area chart, kind of the main reason I want to show this is it's certainly doable in D3. So you're certainly welcome to use these examples or follow links on this code to other examples that can help show you how to do it. Okay, one last example of layouts. Let's draw a donut chart. So for this, we need a pie generator to compute the position, more bad spelling, of each group or arc in the pie. So we're going to have a D3 pie generator, and we're going to pass our data, so this data array right here, to that pie generator. And then we're going to use a D3 arc function, which is actually going to draw the arcs for our donut chart. So the D3 arc function, so this is similar to a line generator, like a D3 line generator, except it's going to draw arcs instead of lines. Okay, so to draw the donut chart, we just pass our data, right, our pie data that we've passed through our pie generator, and we're going to draw it using this pie arc generator function, and then we'll give it just a color scale to make it easy to see. Okay. And then the last bit of example code here is we add some labels around the outside. Yeah, must have been tired putting this together. Around the outside of the arcs. So, so that's what this code here does. Okay. Now, again, D3 has lots and lots of layouts. So the README file discusses, examples of available layouts that you can use. Okay, the idea is we can't just plot the raw data. We have to create some projection or transformation on the data set, which is what we draw. Right? We create bins and we draw those with a histogram. Or we create arc segments and we draw that as a pie chart. So that's kind of the frame of mind you should have when you're working with these layout generators. Okay, any questions so far? Okay, so let's hop to maps. Some D3 map examples. All right. So we've talked a lot about maps, right? Tuesday's lecture was on maps. Homework 3 had a map in it. So let's show some examples of maps. So I've mentioned this before, but right, one of the problems in cartography, right, the Earth is a 3D sphere, right? But we're drawing on a two-dimensional monitor, right? A 2D surface. So to draw the data correctly, we have to do some sort of projection. We are projecting from a 3D sphere to a two-dimensional plane. Okay, so that's kind of the key when it comes to drawing maps in D3. So we have a bunch of, so our header for this is actually a little bit busier than normal. So we have our D3 library. I'm also linking to a D3 GeoProjection library. So this is a D3 library. It's kind of a helper library that they have that has different map projections. So D3 has like a base set of projections that you can use. This one gives you a bunch more, like 40 or 50 more projections. We link to Bootstrap. And then these two calls here are going to link to a library called Leaflet. So there's a slide on Tuesday that talked about Leaflet. Right, it's a way to do tile-based maps in JavaScript. So kind of like Google Maps, where instead of drawing the shapes of like a state or a country, you're adding PNG files, image tiles that you kind of stitch together to make the map. So let's show an example of using Leaflet too. Okay. So what do we got here? So here's our kind of our initial header. That'd be this right here. We have some UI widgets right here. So you can see on the HTML page, we have a drop-down that has several different map projection options. So these are all projections that D3 supports. So Winkle 3, Mercator, Airy, ATOF. So I just went through and picked ones I thought sounded fun. That's how I picked most of these. And Mercator is kind of the most famous one. We have a reset zoom button here. So we're going to show an example of zooming and panning on maps. And this reset button will take us back to the default view. And then we have our SVG, which is this one right here, where we're going to draw the map. Okay? All right, so what are we doing? So the first thing is, let's get a reference to this SVG right here. So we'll get a reference to that guy. We'll figure out what the width and height is. And let's have a variable that's going to store our GeoJSON data set, our world GeoJSON data. So if you look in the folder here, we have a file called world.geojson. And so it's right here in the downloaded code. And we're going to load that with a d3.json call. So if you go look at this file, right, so GitHub's going to try to show you like a nice, right, they're actually going to show you what the file looks like if you visualize it. Let's look at the raw data. Right, okay, so GeoJSON files store geographic data in a JSON format. So this is the general format that they use. So there's, the first thing you're going to see is a type feature collection. So that's right here. So it's just a metadata label. Then you're going to see features. Okay, so this bracket here indicates features is a bunch of, it's an array with a bunch of objects in it. Okay, and so that's going to be an array of the regions or the states or the countries or whatever your geographic features or regions are. Okay, so each region in the array is going to have a type, so like polygon. And it's going to have some geometry call, so like coordinates, right? So coordinates is going to, so this is all the lat long coordinates for whatever this region is. So if we look at it, it's going to say, right, so name Afghanistan. So, and then there's the ID AFG, right? So that's how this that's how this GeoJSON file is storing country-specific data. Right, so if we go just pick a random one down here, okay, Chile, right, Chile, right, type feature, and then the properties, right, name Chile, geometry, right, and then we can get to the coordinates that are in here, okay? Okay, so when we load this data, right, we're gonna load this GeoJSON file and just save it to a global variable that I have. And, you know, so I have a console print here, right? So I can go look at that. So this is what I've downloaded. And then each of these items here is gonna be one country. So that's Indonesia, that's Jordan, and so on. So what we're doing here in the D3 code, so I load the data, I just save it to this world data global variable, which I defined up here. And then I'm going to call a function named updateMap, which is going to draw or update the map based on the world data object, so that GeoJSON file that I loaded, and the current map projection. So whatever I've selected here. Okay. Let's change. Let's see what happens. Oh, okay, cool. So, right, if I change the projection, you can see that I'm using an animated transition to shift between the data projections. Right, so the projections and the raw lat long data have to work together to draw the map. And if I want to draw things on top of the map, right, like I want to label cities or label countries or whatever, right, I need to use the projection to draw those circles, right, so they get put at the correct XY pixel position on the browser. Okay, so what's going on here? So the first thing we're going to do is get the current projection based on whatever this select, so that's this guy right here, whatever this select's value is. So I have a function called getProjection, which is right here. Okay, so it's going to just read the value from this, and then I've got a big if-else statement. It's going to say if the text is equal to GeoMarketer, right, then I'm going to return a GeoMarketer projection. If it's GeoArray, then return something else, and so on and so on. Okay? So this projection, this is going to be whatever my current projection is, my current D3 map projection. The next thing we're going to do is scale and position your map in the SVG. So there's two ways to do this. The first one is you can do it manually. So let me show you the manual version. So I could say something like projection.scale and then .center and then translate. Okay. So what that's going to do is it's going to scale the size of the projection to whatever the height of my chart is times 0.25. So it's going to make it a little bit smaller than the height of my display. The center of the map is going to be whatever the center of the world data set is, and I'm going to shift it a little bit so it's not placed in the top left corner. So if I save that and reload it, right, you can see that like it's okay. It's pretty good, I guess. Right, it's still kind of off the page. So if you do something like this, right, you really have to kind of play around with it, you know, to get it just right. 0.2, that's not bad. Times 0.65, nope, too much. All right, so it's kind of like a guessing thing. Oh, there we go. That's not bad. That's centered, right? Is it? It's not, is it? Okay. Well, The other way you can do it, the better way, I think, is we'll do some responsive design. So based on whatever the width and height of our SVG is, we can just say fit size with the size of the SVG, and then we'll shift it so it's centered. So if I reload the page, right now it's nicely centered. Okay, the next thing I'm going to do is create a geopath generator. This is very similar to a line generator, right? I have a bunch of lat long coordinates. I'm going to draw like a big, a big line, a big connected line for each country. Right? I'll draw one for the US, I'll draw one for Chile, and so on. So it's similar, except now I also need to think about the projection that I'm going to use. So I have to pass the projection as a as a way to help transform how this is drawn. Okay. Okay, and so here, when I actually draw the map, I'm going to use our D3 join approach. So with joins, when I load the page for the first time, right, I have to add the countries to the display. Right, they're not added yet, so I have to add them. If I change the projection, I'm not actually deleting the countries, right? I'm doing this nice animated transition from the previous projection to the current projection. So I can do that with join, right? I can use the update to say, hey, the countries were previously there, and they're still there, but now the projection is a little bit different. So let's move the country from the old projection to the new projection. Okay, so that's what this is going to do. So I can say worlddata.features. This is going to be my array of countries. And then for each country, I'll say, for the enter, right, I want to add the country. I'll append it as a path. So a path is like a complex line. Using this geopath generator. Okay. Now there's this interesting vector effect attribute that I put here. So I talked about this in the comments. So this is basically a way when we do zoom and pan in a minute. I can show you now, but so when I zoom in, you see how the lines are staying the same thickness. So that's what that's going to control. So if I comment this out. Now if I zoom in, you see how the lines are getting thicker. So that's a way to prevent that from happening. So if you're using a map in your own project or in one of the homeworks, right, it's usually a good idea to have zoom and pan enabled. Because if you submit a world map, okay, so if this is your project team, if you create a map with a world, and you can't zoom and pan, I'm certainly going to ask you, a not very nice question, a mean question, like, okay, I want you to zoom in and click on Vatican City. Can you show me the data for Bhutan? Or what's another like tiny country? Honduras. Or right, I'm going to pick some country to be kind of mean. So if you don't have zoom and pan, it's like, well, I can't really do that. So right, zoom and pan makes it easy. So this is like, when you do zoom and pan, this vector effect will keep it from looking, from getting too big. Okay, and then when this update call, what it's going to do, it's just going to call this, it's going to call a transition to geopath. So if we change this, so if we change to a different projection, okay, we're creating a new geopath variable, right? We call this function again. We're going to get the updated projection, right? We get a new projection, a new projection, right? We change from Mercator to something else. So we get a new geopath generator. So we're going to transition to the new, to the new drawing of the geopath. So that's what's going to do this nice, nice shifting. So I don't actually have an exit function here because I don't need one, right? I'm never going to remove this data. So I don't have to add an exit function. All right, one or two more things on this. Graticules. So a graticule, if I comment this out, so that's the lat long lines. So to do that, I can use a D3 graticule generator, and then I can call it, and I can add it. I can enter it if I haven't added it already, and I update it if I change the projection. So this D3 GeoGraticule, this will actually create a data set. And I think if you look at the documentation, there's different parameters you can put, like every 10 degrees you might put a line, or every 20 degrees. So I'm just using the defaults in this example. But what this is going to do, right? If you notice, when I change projection, the country shapes update, but the lines, the lat long lines, also update. So if I comment this out, if I change this here, right, the countries update, but if I add the graticules, the lat long lines will also update. And then the last thing here, I have a border graticule, so a border around the world. That's what this dark line is right here. So if you notice, when I actually change, right, it removes itself, and then it kind of draws itself in after everything's shifted, right? So it animates, and then we draw the dark border around the edge of the world. So the reason that's happening is I'm kind of using I'm not using a join to draw it. I'm just drawing it as a, kind of directly. And then I wait until the other things have finished their transition. I delay drawing this until, until the other animations have happened. I could have done it with joins and it would have shifted too, but I just chose not to. Okay, any questions about map projections so far? So an important takeaway from this, if you put a map in your project, very much recommend you have zoom and pan enabled. Okay, so I can zoom in, right? I can zoom in and click and drag to pan around the map. So how do I do that? Let me show you how we do that. So we do it like this, adding zoom and pan to the world map. So these are not 3D maps, so we don't have rotate. Some of the D3 projections are 3D. The way we do this, it's actually very simple. It's just this code right here. So I create a D3 zoom function, and I create how far in or out I want to be able to zoom. So this is my min and maximum zoom. And whenever a zoom happens, so like if I zoom in, if I do it, it's a trackpad, right? So if I do a 2-finger scroll to zoom in, or double click to zoom in, we're going to call this a function called zoom. And then we're going to attach it to our map SVG right here. So that's going to attach this zoom function to our map SVG. So this doesn't only work on a map. I could put this on a scatter plot or a bar chart. Any D3 SVG that I'm using, I think you can attach a zoom to it. So when zoom is called, basically what I'm going to do is just transform I'm going to select the items on my map. So I have countries, that's each country. When I added the countries, I gave them a country class right here. Right, so my countries have a country class, my graticules have a graticule class, and my boundary has a boundary class. So I'm going to select those objects and just transform them based on whatever my mouse-driven transform was. So however far I zoom in on the mouse, that'll be stored in this D3 event transform. If I zoom in a little bit, that's what the transform is if I pan, and so on. So if I did something like, let's say I did this. Let's say I only did country and boundary. So if I save that and reload it, when I zoom in, right, so I'm not actually transforming the gradicules now. So. And then finally, this reset zoom button, if I zoom in and I click reset zoom, that'll just zoom back out to the default zoom. So D3 zoom identity, that will take you back to your default zoom and pan. And you might notice here I say update map. So the reason I do that is in the code logic, if I zoom in and like pan and stuff, if I change the projection, I actually just call reset zoom. So that's the function I call. So that's why it zooms back out and then it changes the projection. Okay? Okay, so 2 more quick examples and then we'll be done for today. So this next example is we're going to show you how to extract regions and add layers on top of a map. Okay, so we have a map. Okay, so now we have another SVG that we call USA SVG. We have 2 data variables. We have some map data. We also have a city data set. The city data set we can draw as circles on top of our map. And the other thing we can do is if I click on a state, I'm going to extract that state's, I'm going to find that state's shape, right, that state in the GeoJSON file, and then I can draw just that state. Right, so if I click on California, draw California, Pennsylvania, so on. Okay? All right, so what are we doing here? So we have another projection. So we're going to use a projection for the USA map. The one we're going to use is called GeoAlbers USA. So the interesting thing about GeoAlbers is you might notice this particular projection, right? Alaska is like way over here, Hawaii's way over there, right? It actually the projection moves those and resizes them, right? So it's kind of this classic USA map where Alaska is like the size of Arizona, Hawaii is like the size of Vermont. So that's all based on this GeoAlbers projection, GeoAlbers USA. All right, so I could do something like GeoAlbers. So if I do that and save it, so this is actually, we don't do this moving and resizing. So GeoAlbers is like I can use this for a worldwide projection, right? But I don't have Canada or Mexico or other data. So back to GeoAlbers USA. And so you notice here, we're doing this fit size, right? This nice fit it into the SVG. We have our geopath generator using our USA projection, and we're going to draw the map. We're going to draw our USA map data, which is this US GeoJSON file. So instead of countries, now it's states. So there's 50 states. So there's 50 states we're going to draw on this map. The other thing that we're going to do is we're going to add a click handler. So if I click on a state, I'm going to draw that selected state. So that's what's going to do this right here. If I click on a state, then I call this draw selected state, which is going to get just that state's data and draw it. Okay. So let's look at draw selected state. So draw selected state. So I pass it a state name. It's like Arizona, California, whatever. If the state's currently shown, then I'll just delete it. So if the state's shown, and I click it again, it should delete it. Maybe not. No, that's not working. I guess there's some bug in my code. Oh, sorry, if a state is currently shown. Okay, so if a state's currently shown above the map, then I'll delete that state and draw the new state on top. So that's what it's doing. Then I'm going to create a glyph with class selected state, and I'm going to add a rectangle and a text label to it. So if we go look at this code here, I go look at that right there. I create a glyph, so a G. I append a G. I give it a class called selected state. So you can see that reflected here. And then I put it in the center of my SVG. And then below that, I'm going to add a rectangle and a text label. So that's the rectangle, and there's the text label right there. Okay, so the rectangle is just this outside box, and then the text label is whatever the name of the state is. Okay, so there's the rectangle code, and then there is the text code. All right, now the trick for this one. Whatever state I've clicked on, okay, so I click on Texas. I want to get the data for Texas only, right? And I'm only going to draw the Texas, right? So my US GeoJSON file has lots and lots and lots of states in it, right? So if I can search for Texas, right? So this is Texas right here. Right, so I need to go through my array and find just this guy right here and take him out. So the other thing we're going to do is we're going to create a projection in a geopath just for my single state. Okay, so California, right, the lat longs for California are like way over here. The lat longs for Florida are like way over here. But I want to, whichever state I pick on, I want to center it in the middle of my box that I've clicked. So I need to get the centered, a projection that fits just those. So let's extract the data from our GeoJSON and create a new GeoJSON data structure that only contains that state. So it only contains Texas or Arizona. So to do that, I'll use a filter function, and I'll say the properties name. So this is in the GeoJSON. The properties.name has to match whatever state I've clicked on. And then I'll just put that in a GeoJSON data structure that has one state inside of it. So that's the GeoJSON for just Texas. So now for my projection, I want it to fit whatever Texas's kind of lat long boundaries are. So I'll create a projection just for that and a geopath generator, based on that projection. And then I'm going to draw just that state on top of this glyph that has a white rectangle, a label, and then I draw the state right here with this code right here. Okay. So geopath is going to be just for my state. And state map data is just the Texas GeoJSON. Okay, any questions about that? So why could this be useful? Well, let's say that I am doing a project. I have a map, right? Map's my overview. I want to show details for one specific state. This is code to extract just that specific state's GeoJSON data. If I click, let's say I want to show a bar chart for Arizona, I could draw the outline of Arizona and show this is the state I want. Or if I want to compare two states against each other, I can show the outlines of the two states and plot their data in a way that let me compare. So that's the reason I do this specific illustration. Okay, one last example. Got 3 minutes? Is that how long I have? Okay. Okay, last example. Using Leaflet for maps. So way back up here in this USA map example, I had a function called draw leaflet that was commented out, so let's stop ignoring that. So we'll look at this now. So draw leaflet is a function that's going to, let me save this. It's going to draw, let's see. There we go. There we go. Yeah. That will draw a leaflet map on my in an SVG. So this draw leaflet function is right here. And the reason I call it from here is because on this map here, there's this checkbox called show cities. So I don't show this code, but if you want to put it on your own, I mean, by now you all can look this code to figure out how to do it. But there's this cities data set that I also loaded up here. So US state capitals. So this is a very simple data set. It just has the capitals for each US state. So the name of the state, name of the city, and the lat long coordinates. So here, there's a function to draw those. Where do I do that? Yeah, so I have a show cities function. It's very simple. It just draws the cities on the or removes the cities on the map. So we're going to add those on this leaflet map here. So you can see that Phoenix has a marker on it because it's the capital of Arizona. Santa Fe, I think that's Santa Fe, right? Santa Fe is the capital of New Mexico, and so on. So in this draw leaflet function, we're going to use that cities data set to draw markers on leaflet. So leaflet's pretty simple. Their website has really good tutorials and documentation. So if you want to use a leaflet map, you're certainly allowed to. That's the place to start. So I can create a leaflet map and add a tile layer. So what this is saying is I'm adding an OpenStreetMap tile layer. That's what this style of tiles. This is an OpenStreetMap layer set. There's lots and lots of layers out there. I can set things like the maximum zoom level, right? So how far in I can zoom. And I add it to this leaflet map that I've created. And then for the city data that I'd previously loaded, I just add them as leaflet markers. So that this is the rendering style that they have. Okay. And then there's leaflet has handlers. Like if I click on a marker, you know, I can get it. You know, I can catch that in JavaScript and call some function on the side if I wanted to, or pop up a tooltip, or you know, overlay a visualization on top of it. So leaflet has functionality to do all of those things. So this is another option for your projects if you want to do a leaflet map instead of drawing a normal GeoJSON file. Okay, so that's it for today.